And we're going to talk about what makes a function odd or even, so odd and even functions, or they might be neither. Many functions are neither, by the way. So, we left off doing this stuff here where we were talking about domain and range, and we just did a problem like that on that review sheet. But that last one, problem number 10, talked about even and odd functions. So this graphically is kind of an easier way to figure out whether a function is even, odd, or neither. So reading here, a function is even if it's symmetric about the y-axis. And what that means is if you fold it up like a book, one side flips on top of the other side. One side lands on the other side. So for example, that is an even function. Because if you fold it up, the left side lines up right on top of the right side. Okay, that is not. Because if you folded that up, that left side would look like that. It doesn't line up directly on the right side would not line up directly on the left side or vice versa. So a function is even if it's symmetric about the y-axis. When you fold it, both sides line up on top of each other. Fold it along the y-axis. A function is odd if it is symmetric about the origin. All right, what that means is if you take the graph and you turn it upside down, does it look exactly the same? Okay, so you take a graph and turn it upside down, does it look exactly the same? So this is an odd function. If you turn that upside down, it looks exactly the same. This is not an odd function because that V shape would be facing downward if you turned it upside down. So an even function is if you reflect it over the y-axis, it matches up. An odd function is if you turn it 180 degrees, it looks exactly the same. And if it doesn't do either one of those things, then it is neither. So in that case, that means that this function here, that is an even function. And this is also an even function, that parabola, because if you reflected it, the left side and the right side would line up right on top of each other if we reflected over the y-axis. Now the part B is an odd function because when you rotate that 180 degrees, it looks exactly the same. Part C is neither. It's neither because if we reflected it over the y-axis, it would look like that, like the vertex would move. And if we rotated it 180 degrees, it would look like that. Okay, it would not look exactly the same. So that is neither. So think about our parent functions that we talked about, and that's the connection that we're making, whether or not they are even or odd. So looking back over parent function or on our other sheet, I'm sorry. But this would be an example of an even function. Okay, if reflected over the y-axis and the left side would fold right on top of the right side. That would be neither. All right, so far so good. Any questions yet? All right, because now I'm going to show you algebraically how you figure out whether it's even, odd, or neither. And the key is this notation right here. So let me kind of explain what that means. What that means is in the function, you're going to replace x with negative x. You're going to do that to test for whether it's even, odd, or neither. You always replace x with negative x. If the function comes out to be the exact same thing, so it comes out to be equivalent, then it is an even function. So if you plug negative x in for x, and they are both equivalent or equal, that means it is an even function. if you plug negative x in for x and you get the opposite of the original, that makes it an odd function. And if some of the terms, yes.
I know we can do it this way, but also can we just like you said with the pictures, like you can see is x3 that, and then can't you just like by heart know the pictures in your head, and then you can determine if it's even or odd?
Yes, you can, if it's one of the core functions or one of the parent functions. Yep.
Okay.
But now remember, because that you have x to the third, you also have to worry about this thing here also. And same
Okay.
thing here, you have x to the third, you also have to worry about the -1. If it was
Okay.
just x to the third, that is an odd function and you could just move on. Yeah, good
Okay.
question. So let's test this first one. I'm going to plug negative x in for x. So that's going to be negative x to the third power and then minus negative x. Well, negative x to the third power means negative x times negative x times negative x. And when you do a negative times a negative times a negative, you do get a negative x to the third. And then here, negative x times negative x will be plus x. So notice what happened. This is an odd function. It's odd because this term is the opposite of that term. Okay, that x to the third became the opposite of itself. And this term is the opposite of that term. That negative x became positive x. If all the terms become the opposite of the original, that makes it an odd function. Now to test for part B, we're going to do the same thing here. We're plugging a negative x in for x. So I get negative x, quantity squared, and plus 1. Well, negative x squared is negative x times negative x, which is positive x squared. And so I have x squared plus 1. That means that is even. It's even when your result is the same as the original. X squared was the same as the original x squared. And 1, of course, is the same as 1. So let's try the third one. We'll replace negative x with x. I'm sorry, x with negative x. So we can do negative x cubed minus 1. So negative x cubed, again, is negative times negative times negative, which will be negative x to the third minus 1. Now in this case, that negative x to the third is the opposite of x to the third. So I'm thinking, oh, maybe it's odd. But negative 1 is the same as negative 1. So this one changed and this one stayed the same. Therefore, that is neither. If there's a mixture that some change and some don't, that means it is neither even or odd.
Wait, can you explain that again?
Yeah. You're going to plug negative x in for x, okay? So if you plug negative x in for x and the result is the opposite, that makes it an odd function. So for example, we plug negative x to the third and then minus negative x. Well, when you simplify that, we get negative x plus x. Well, this negative x to the third is the opposite of the x to the third, and x is the opposite of negative x. That's why that is an odd function, because all of the terms were the opposite of the original. Now, if all the terms are the same as the original, which happens here, then it's even. Because when I plug negative x in for x, well, when I square it, it still stays positive. So I get x squared is the same as x squared. And 1 is the same as 1. And so if they all stay the same, then the function is even. But if there's a mix, some are the opposite and some stay the same, then it's neither. So, and that happens in this case. In this case, when I plug in negative x for x, well, negative x to the third is negative x to the third. That's the opposite of the original. But for this term, negative 1 is the same as negative 1. That's the same as the original. So 1 was the opposite, 1 was the same. We have a mixture, so that means the function is neither odd or even. All right, any other questions?